Welcome to the session on forces and friction, review exercises. The objectives for this session are to review previous topics through exercises, namely, apply Newton's second law of motion, F equals ma, to vector forces and acceleration, and use Pythagoras Theorem and trigonometry to find missing sides or angles. Pause the video and have a go at these review exercises. When you're ready to view the solutions, press play. We're going to take a look at some background theory before launching into the first exercise. Newton's second law of motion. The force required to accelerate a particle is equal to the product of the mass of the particle and the acceleration produced. In other words, F equals ma. Note that this equation can be used to solve problems involving vector forces which act on particles. In this version of the equation of motion, F equals ma, F and a are vectors. Write acceleration as a two-dimensional vector, pi plus qj meters per second squared, as shown here, or pq meters per second squared, as shown here. So let's now take a look at the first exercise. The forces F1, F2, F3 and F4 are equal to the values as shown in the exercise. These forces act on a particle with mass 7 kg. We are required to find the acceleration of the particle. So let's solve this. The resultant force is equal to F1 plus F2 plus F3 plus F4. So here's F1 plus F2 plus F3 plus F4. (6i plus 2j). Now we know that F equals ma. Therefore, 6i plus 2j newtons equals the mass, 7 kg, times the acceleration. So F equals m times a. And therefore, acceleration equals 1 over 7 times 6i plus 2j meters per second squared. Now let's take a look at Pythagoras Theorem. Pythagoras Theorem states that in a right-angled triangle, the area of the square whose side is the hypotenuse, the side opposite the right angle, is equal to the sum of the areas of the squares on the other two sides. So in other words, for the right-angled triangle shown on your screen, we have that a squared plus b squared equals c squared. So let's take a look at exercise 2a. We are required to find the size of the hypotenuse in the diagram shown. So let's solve this. The hypotenuse is given by the square root of 3.5 squared plus 2 squared. So here's our hypotenuse, in other words c, in our theoretical diagram. And here's our side A, 3.5. And here's our side B, in other words, the value 2. And calculating this gives us that the hypotenuse is 4.03 centimeters to 2 decimal places. You will also recall that in a right-angled triangle, 3 trigonometric functions are as shown. Sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. We can apply this to exercise 2b, where we are required to find the size of theta to 1 decimal place in the triangle shown on your screen on the right-hand side. Notice that we have the opposite to theta and we have the adjacent to theta. Therefore, we need to use the formula for tan, in other words, opposite over adjacent. And plugging in these values gives us that tan theta equals 2, which is the opposite, divided by 3.5, which is the adjacent. Therefore, theta equals tan inverse 2 over 3.5. And plugging this into your calculator should give you theta equals 29.7 degrees. This brings us to the end of this session. If you have understood its contents, you should be able to apply Newton's second law of motion, F equals ma, to vector forces and acceleration, and use Pythagoras' theorem and trigonometry to find missing sides or angles. Thank you very much for listening.